First thing on the agenda this morning, folks, is the Phoenix Power Unit. The Phoenix Power Unit comes in all sorts of prime movers. We have the Briggs & Stratton 3.5 horsepower 4-cycle gasoline engine. We have electric, AC, 110, 220. We have DC 12 volt. We have air over hydraulic and hydraulic over hydraulic. This morning we're going to start off with the basic power unit, the gasoline powered Briggs & Stratton engine, which is our prime mover on this power unit right here. The Briggs & Stratton engine is a 3.5 horsepower 4-cycle lawnmower engine. It uses straight gasoline, there's no mixing required. It has a throttle control on the front right here, and the throttle has two marked positions. It's stop and start. Run position is anywhere in between the stop and start, and you can run it either in idle or any speed up into full 3000 RPM. The gas shutoff is also mounted on the front right here. You can see it's marked in the open and close position. It's a quarter turn valve. It has a muffler guard. The muffler guard is important because even after an hour's running time, the muffler guard remains cool, so that if you inadvertently drape your hose over it or rub up against it, it won't burn you or the hose. As I said before, the engine is basically a lawnmower engine. It has a high impact plastic top, and built into this high impact plastic top is a gas tank. It will run approximately an hour and a half on one full tank of gas. That's irregardless of whether it's in full operating mode or whether it's an on idle. The reason I emphasize the lawnmower engine is because we're in a little town called Hatboro, Pennsylvania, and within a mile of us are three major servicing parts outlet centers for Briggs & Stratton engines. So parts and service are almost universally available for this little engine. This engine has a 2 3/4 inch shaft, which fits into an engine to shaft or engine to pump adapter, which drives this pump directly. This is an axial piston pump. It has a eccentric wobble plate, or a plate cut at a slight angle, and when it rotates, this plate drives the pistons up and down. That's the reason it's called an axial piston pump. It has 6 pistons, 2 of them for fast advance or high volume, they're large pistons, and 4 of them for high pressure or high pressure. It has a automatic pressure relief valve on the side that's either set with a screwdriver or an Allen wrench. Underneath this, inside the pump itself, is a sequencing valve, and this is a valve that switches from high to low pressure. The two dual ranges, or the 2 ranges for this pump, without changing RPMs, will change the speed of the tool operation. The first range is from 0 to 1200 psi, and it pumps almost 2 gallons a minute, 1.8 GPM at that range. At 1200 psi, the pump automatically sequences and drops the flow from 1.8 to 0.8 gallons a minute, and the pressure range then is from 1201 psi to 5600. Our operating pressure for the Phoenix tools is 5600 psi maximum, and they operate extremely efficiently at this power and at these flow rates. A reservoir. It's a die-cast aluminum reservoir with rubber feet on the bottom. The reason we mount the rubber feet on the bottom is because these engines vibrate, and the vibration then doesn't dance the power unit around. It'll sit there and it'll vibrate slightly on these rubber feet. It also has a slightly self-leveling effect. The capacity of the reservoir is 1.5 gallons, and we measure the 1.5 gallons to the full mark on the liquid level gauge mounted on the front of the unit. So there's never any question about whether the unit is full, empty, or half full. You just look at the liquid level gauge and it gives you an immediate readout. The pressure relief valve, or the dump valve, is mounted on the reservoir cover. The reservoir cover is mounted on top of the reservoir itself, and the dump valve, or relief valve, is mounted on the left-hand side with the handle outboard. The handle, as you can see, is protected by the roll cage when it's operated either forward in the pressure position or to the rear in the dump position. When it's in the rear position or the dump position, it relieves pressure not only coming from the pump, but also from the tool and the hose lines that are connected to the pressure outlet. Pressure outlet is traditionally on the left-hand side, or the left-hand hose, when you're facing the direction of flow. This is a rescue tool. This is the Phoenix rescue tool. It is a full-size, full-capability rescue tool. It pushes, pulls, and cuts. It pushes with the jaws, it cuts with the blades that are mounted in the center of the arms, and it pulls with belts and shackles. We use polyester belting and shackles for pulling rather than chains. We'll show you that a little later. As I said before, it opens 32 inches, so it's a full-size rescue tool. It opens with the initial force, or when they first start to open up, of 12,000 pounds, and it goes from 12,000 to maximum opening force of slightly over 18,000. Its pulling force starts at 15,000 in the full open position and goes down to about 11,000 when it's in the closed position. Total weight for this tool, functioning, ready to go, is 56 pounds. The cutter opening is 10.5 inches, but effectively cutting is only done with the 8 inches of the opening. Operation of the tool is very simple. The 4-port 3-position spool valve is mounted on the right-hand side of the tool, so it can be operated with your right hand. Thumb pressure to the top of the trigger operates the tool in the closed position. Pull the opposite side with your finger like you were pulling the trigger on a gun. Operate the tool to the open position. The tool takes 6 inch-pounds of force to operate. The tool has the cutter blades mounted in the jaws, and they're easily field replaceable. The way they're removed is you loosen 2 Allen screws that hold the jaw in place, and the jaw simply slides off. The jaws are symmetrical, or one jaw fits both sides, so it's very easily replaced. They don't go bad in pairs, and if you chip or crack one in the field, it's very easy to replace it. You just slide the new jaw into place and replace the screws. There is no torque specification on how tight the screws should be. You just put them in, tighten them down, and you're back in business. The jaws themselves are easily to replace. You just remove the pin that holds the jaw in place, and the jaw slides off the end of the arm. As you can see, the pin fits flush in the jaw, and it's not easily dislodged, even though you may be involved in some very heavy pushing or pulling of sheet metal. And the pins fit flush both inside and out. To replace it, simply put the jaw back in place and put the pin back in place. The jaw opening time is roughly 20 seconds in unloaded condition, and about 50 seconds under full load. The pulling package, or the belts and shackles as we call them, come in a Cordura nylon bag with a shoulder strap. The idea is you can throw the shoulder strap over your shoulder, it keeps both hands free, and carry your pulling package to the scene. The pulling package is made up of 2 48-inch continuous loops that are covered with an abrasion-resistant cover. You may recognize it for 1.5 inch single jacket hose or washdown hose. This prevents the continuous loops from being abraded or cut when they're passed through a windshield or over a sharp object. The shackles come with a continuous 12-foot belting that is fastened to the shackle. The shackle is attached to the jaw by means of a fast pin. It's a 3/4 inch pin that fits through the hole in the arm. This is simply done by inserting it in through there. Now, the 48-inch continuous loop is looped around whatever we're going to pull. One of the belts and shackles is mounted on each arm. Then the tool is opened fully to its 32-inch opening, and the slack is taken out of the system. The slack is taken out of the system very simply by pulling gently on the belting. The shackle is set up much like an automobile seat belt, and it moves freely in one direction, but it locks when it's pulled in the other direction. New power unit arrives, it'll arrive empty. First thing to do is to fill the oil. Oil has a dipstick and it has a clearly marked indication of when it's full. The unit will arrive with a bottle marked engine oil. It's 1 pint, and take the cap off the engine oil, pour it in the fill open, and check with the dipstick to make sure that you have the engine full. Do not overfill the oil or it will get into the fuel mixture and smoke profusely. The next thing to do is fill the hydraulic fluid. Your unit will arrive with 2 1-gallon containers of glycol-based hydraulic fluid. The glycol-based hydraulic fluid that we use is compatible with ethylene propylene rubber, and the procedure is to fill it with 1.5 gallons of hydraulic fluid. The other half gallon of hydraulic fluid will remain in the container that it's shipped in, and you can use it for replenishment anytime during the life of the power unit. It ages well, it does not go bad, it does not settle out, and it has an indefinite shelf life. The liquid level gauge mounted on the front of the power unit has a slight lag from the time the material is poured into the power unit until it indicated on the level gauge. So fill the unit with 1.5 gallons and then stop. As you can see, it's starting to appear in the liquid level gauge now. The last thing you should do is fill the fuel capacity. Fuel capacity is about 1.5 quarts, and the fuel gauge or the fuel fill opening is on top here. It's the opposite of the oil. 1.5 quarts will run this tool for approximately an hour and 30 minutes. Fill that, and then your tool is ready to start and ready to run. The next step in the tool startup procedure is attach the hoses. The hoses will come marked, one with a red piece of tape and one blank. The red piece of tape goes to the red line on top of the dump valve. You can see it marked very plainly on top of the dump valve. Screw the hoses on. You can go on finger tight. It's a ground fitting, and you screw the red matching the red and the plain matching the plain. As we mentioned before, the fill opening or the pressure line is traditionally on the left if you face the direction of flow. So if there's any confusion or you ever lose the tape off the marked hose, remember the pressure hose goes on the left-hand side, and on the business end or the connector end, the pressure outlet is always on the male side. The hoses are connected, and now before you start up the power unit, make sure that you tighten the swivel with a 5/8 wrench. Make sure they're tightened securely. It's a 37-degree ground fitting, and they'll tighten up, and you can feel that the hose is tightened and it's bottomed. They're sufficiently tight, we're ready to go. When starting up a new power unit, it is essential that we maintain a prime on the power unit, or secure a prime. To To do this, generally it's important to tip the new pump in a 45-degree angle and pull through several times slowly to get the pump to pick up the prime and to get the air out of the bottom of the pumping unit. Then set it back down level, put the slide in the start position and pull on the starting lever. Let the engine run for a few minutes without putting pressure on. Then connect the tool and the power unit. But you may just connect it. Once you started the power unit, push the pressure dump valve to the pressure position. Then operate the tool. With the stick into the tool as to whether or not you have a good time on the tool. Let's check it for speed. This is the Phoenix cutter. This is a companion piece to the Phoenix rescue tool. Although the rescue tool has extensive cutting capacity, this tool is meant to augment what you can presently accomplish with the tool. The idea, the design of this tool is to have one fixed blade and one movable blade. And the idea is to make one cut, very simply, just like you do with any other cutter, by putting the material to be cut in between the two blades and operating the valve to the closed position and simply cutting the piece that's in between the two blades. The tool differs from most other cutters, which are symmetrical, in the fact that this blade, although it's fixed, has to withstand the force that's put on by this blade, and this blade closes with approximately 50,000 pounds of cutting force. So to operate the tool, it's very simple. You connect it to the power unit, you push the control to close, you pull it with the control with your finger to open, just like you do on the rescue tool. It has a handle on each side to use the tool in the horizontal position. It has a third handle on the other side to use it in a vertical position. To operate the tool is very, very simple. You start up the power unit, just like we did in the other operations. In a fully closed position, you'll see that the movable blade has a significant overlap on the fixed blade. This gives you a much wider, much deeper cut and allows you to put the fixed blade through the hole that you make with the movable cutter blade. This allows you to make a continuous cut like an old-fashioned can opener and continue to cut across whatever you were working on. This is the reason we have a continuous cutting rescue tool as a complement to our Phoenix cutter, which has the normal cutting capability of symmetrical cutters. This is the R50 ram. This is the ram that complements the opening spread of the Phoenix rescue tool. This tool opens at 32 inches. The rescue ram, as you can see, in its closed position is slightly less than 32. The idea of the design of the rescue ram for the R50 is to fit inside the opening made by the rescue tool, so that from 0 to 32 inches is handled by the rescue tool. If you have to extend your scope beyond the 32 inches the opening capacity of the tool, then you insert the ram, extend the ram on up to 50 inches, and remove the rescue tool and go on about the demonstration or rescue. To show what I mean about this, you can see that the rescue ram in the closed position will fit in the opening that's made by the rescue tool. This precludes the necessity of buying two separate rams, one to fit inside the opening of the tool that fits inside, that will open wide enough to allow the use of the long ram. This ram extends to a full 50 inches. The operating control of the ram has been removed from the ram itself and is on a separate valve. This valve is hose mounted and is operated with one hand. To operate the ram, simply grab hold of the handle and push with the thumb till the ram is in the fully open position or till it has taken up the slack that you want it. You release this, it returns to neutral. To close the ram, you get it and push it from the other side. It's very simple. And we'll start up the power unit and show you what we mean by the operation of the ram. That's the R50 Rescue Ram. It opens with 15,000 pounds of force and has a closing pulling force of about 7,000 pounds. Well, here we go again, folks. It's back to the junkyards. What more fitting place to show you the capabilities of this type of equipment than an auto recycling center, where we can help them along on their way to recycling an automobile. Mr. Bullock has made a car available to us today to show you why, wherefore, and what on why we designed this tool the way we have and how it can work for you in emergency and rescue situations. We're not going to train you with this film. We're going to show you the capability of the equipment and make you think. The only way you ever become confident in use of this equipment is by use. Hands-on training with instruction by a competent professional. This film is for your information. I hope you enjoy it. First, we're going to show you the Phoenix Rescue Tool. The Phoenix Rescue Tool is what we call a complete powered rescue tool. It has push, pull, and cut capabilities. For this little session, we're going to use the 4-cycle Briggs & Stratton powered hydraulic power unit with a 16-foot hose. We'll use the standard Phoenix tool package for this demonstration today of the tool's capabilities. What we'll show in this first session is pushing down on the top of the sheet metal with the window intact and the front door, deforming the sheet metal and opening the seam wide enough to get the tips of the tool in, breaking the hinges off and cutting the A-pillar out of the windshield and removing the glass. I think we'll do away with the sound effects here and go back to a little noise over, which I'll contribute. You've seen we've gone in sequence here and done the things up to this point. Now removal of the windshield becomes fairly easy, whether it's set in rubber or mastic. Once you spread the top away from the bottom of the windshield, the sheet metal bends, the glass can't stretch, and it'll either break the mastic or the rubber loose, top and bottom, and it'll make it possibly to manually just by hand remove the windshield. Next step in this operation is to cut the center pillar. You'll notice that we only have to put width of one arm inside the car to make the cut. We do, and then when we close the tool, the inside arm is pulled out, and we never go over parallel with the inside of the car. Matter of 12 seconds or so, we've cut the inside pillar. With both doors closed or with both doors open, makes no difference at all. We'll follow this up by the next step in folding the roof back or removal of the roof, and this will be to put a notch in the back of the roof. Now, we place the one arm up against the interior of the car and just simply close the tool. The inside arm is pulled up against the top of the car, and we make a large, deep opening in the roof rail and destroy the integrity of the roof on this side, which will make it much easier for us to fold back later. Next, we're going to show you the pulling with the belts and shackles attachments, which is the logical sequence for us today because we're working our way around this car. We'll show you the ease with which we can attach these things, rig them, and actually pull the steering column. We pointed out before that these are easier to carry. As you can see, they weigh about 20 pounds and they come in a little Cordura nylon bag. And there's two 48-inch continuous loops and two shackles. One loop is just simply looped around the steering wheel, and it's clipped in the hook with the keeper on it on the end of the 12-foot belt. The belt has a shackle on the other end, and that is simply attached to the tool of the arm, or the arm of the tool, through the hole in the jaw. The jaw does not have to be removed for this operation. The shackle is simply slid over the jaw, and the 3/4-inch fast pin is slipped through. This is done on both sides. The other end of the belt is attached to something firm or solid underneath the car, an axle, a tie rod, almost anything, and the slack is simply taken out of the belt, much similar to the way you take the slack out of your seat belt, just by pulling on the loose end. Once this is done, the tool is completely open, and now it is closed, and the pulling is completed. Now you can see the tool is closing now and is taking the slack out of the system, flattening out a little sheet metal on the front and pulling the steering column. We can use cribbing with this belting, or we can do it without the use of cribbing. One reason is the wide belting distributes the weight over the dashboard and pulls the dash and the steering wheel up. Once the tool comes to a complete close, you can see we've pulled the steering column up about 7 or 8 inches, which would probably be enough to complete a rescue. However, if a second pull is needed or desired, simply open the tool up and the slack is again taken out of the system. A way to do this is, as the tool is being opened, the slack is removed from the system. We do it again the same way by pulling the loose end, which is similar to the same type of system that is in your seat belt attachment. When the tool is completely open, it is time to pull again. I doubt seriously that it would be required to pull the steering wheel much further than this, but sometimes it's necessary to get the pedals, the brake pedals, up off the floor. When you pull the dash up this far, it also pulls the brake pedals off the floor, clearing the inside of the car. Keep an eye on the cutter blades as this is being done, as the cutter blades should stay flush against one another. If they start to separate, stop, open the tool up, get another bite, and reclose the tool. The shackles are simply removed the same way they were put on, by pulling the pins straight out, and the shackles are removed. Now we can get back to the cutting operation, which is exactly what we're going to do. This tool is open from using it in a pulling mode, and we just simply put it around the A-pillar, or the pillar in the front of the car, close the tool, and crunch. It did it again. Seems pretty effortless, and it is. The only thing the operator is contributing to this is carrying the tool to position and 6 inch-pounds of force that he used to operate the control. The center pillar here is cut with both doors intact, as well as the seat belt. As you can see, the tool sticks inside the car no further than the width of one arm. And when it closes, it pushes towards the outside, neatly cutting the center column. The next step in the operation is move to the rear. And here we cut the notch in the roof on the other side, completely destroying the roof integrity and just leaving a sheet metal to fold back in the middle. Give you some idea of the size of the cut, we'll look through this little hole here after we put it through the roof. Now that cut is completed. And to remove the tool, you simply open it, and gravity helps you along with the rest of it. Obviously, the next step is folding the roof back. This shows you the total capability of the Phoenix Rescue Tool: push, pull, and cut. It's economy in manpower, economy in equipment, economy in effort and energy. It's the complete rescue tool. Now we'll show you a little different facet of the rescue tool's capability. We remove the top so we aren't able to push down on the top of the door to deform the sheet metal. So we simply grab a hold of the edge of the door by opening the tool 4 to 6 inches and slipping one jaw inside the seam between the front and the rear door. Close the tool, clamping the sheet metal and bending it back. At that point, we insert both jaws of the tool, just the tips, and pry the sheet metal apart far enough to get a good grip and get started. It slips loose here, but it gives us a big enough opening to get the jaws in. From that point on, it's all the same. We try and stay as close as possible to the door latch. If you deform the sheet metal and fold it up, it's like a big spring. You store energy in it, and when the door latch finally breaks, the door snaps open. If you can stay right next to the door latch, generally when you break the door latch loose, you don't have the energy stored in the folded sheet metal, and the door just simply pops loose. The lock is broken. At that point, you can swing the door open or pry it open using the tool's 32-inch spread and continue on to the next step. The next step in this case is simply breaking the top hinge and the bottom hinge and removing the front door. While you're doing this, it's interesting to note that it moves fairly rapidly closing, but slows down as soon as it gets in doing useful work. That means we've exceeded the load limit, and the sequencing valve has slowed down the flow, so we slow down. One of the interesting things is we can see as we gently remove this door that the door hinges actually fracture or are bent apart, and this we can observe because of the slow mode. The door comes off, and we're in business. That was the Phoenix Rescue Tool. I hope you were impressed by what you saw. I certainly was. The next thing we're going to show you is the Phoenix Cutter. This continuous cutter, as we call it, is designed to complement the cutting capability of the Phoenix Rescue Tool. As you've seen in this film already, most of the rescue functions can be done simply with the rescue tool itself. All the cutting functions for removing the roof or taking the doors off are done by the Phoenix Rescue Tool. So the CC cutter, or continuous cutter as we call it, is designed to do more than that. That's to make a continuous cut. You make the first cut. The second cut is made by simply sticking the fixed blade on the cutter through the hole you've made with the first cut and simply closing the tool again. This, you see, the sharp point pokes through the sheet metal and closes. There's a great deal of overlap in this cutter, and that's intentional. The idea is to open up a big enough hole so you can stick the fixed jaw through and continue the can opener operation. It may not be neat, and it may not be the fastest in the world, but it sure works like hell. And you can start here and cut as far as you have patience to go, or necessity or desire. You can see how it works. There's one single blade moves, the top blade, and the bottom blade is fixed. We're kind of limited on what we can show you here just by what is left of the car after we got done with the rescue tool, since we're doing this on a single car. It used to be cars were plentiful in our area, but since the advent of the powered rescue tool, there seems to be a shortage. I don't know whether people are taking better care of them because they're more expensive, or you're tearing them up so fast with the rescue tool practice and training. Here we're cutting the door frame in the front of the car from the opposite direction. You can see the fixed blade is on the bottom here, and the movable blade comes through from the top. You can see it gives you a better example of the type of and size of hole we're putting through the sheet metal. After this, we'll take a whack at the door hinges. First, we'll cut the top hinge in the rear door of the sedan. If it's necessary to remove the door hinges in this manner without prying them loose, then I would guess that this would be the tool to do it with. You simply put it around the door hinge and close the tool. You see there's very little fuss or muss, and obviously no stored energy in that piece. We'll move down to the bottom hinge and do the same. The door will fall off. Clunk, and that's all there is to it. Next, we'll show you the cutting of the car frame, sometimes it may be necessary to put a hole in the frame to spread it with the ram, or for some other reason I can't think of right offhand. We don't do it all in one clunk, but we certainly do it. First cut is through the sheet metal, primarily to get it out of the way. The second cut, of course, takes the rocker panel completely out. And then the third cut, I guess, just to make sure, and maybe even a fourth, depending on how far you want to cut the frame. Now we're inside the car cutting out a floor pan. As you can see, the frame is cut through. We've also cut the frame in the front of this car, the door hinges, and a wide pillar in the back. You can see what happens to the frame when you cut it. We could actually remove the whole side panel had the door been intact. This is the CC, or continuous cutter. Next, we're going to show you the R50 ram. There isn't a whole lot left to show, but generally the R50 ram is used to extend the opening capability of the 32-inch tool. This ram fits inside the opening made by the tool. Unfortunately, once you make an opening with the tool, there isn't a whole lot left for the ram to do. But here we put it in the door frame and extended the door frame. You can see it pushing the front of the dash up here. The whole front end of the automobile is moved, and we move it about 4 or 5 inches. The central pillar of the car starts to give, and that's as far as we get with the thing. But the interesting aside is we had our 50-inch opening now. We pushed the pillar back and pushed the frame up. Whatever we were after, we got it. 50 inches opening. Once we've cut the frame, you can see what happens when we put the ram in after the frame has been cut, and generally the same area. We extend easily to the 50 inches by simply pushing the frame of the car down and pushing the front of the car up. The ram has an operating control in one hand. As you can see, the operator is remote from the ram itself and is operating the control with his one hand, right hand there. You can see what happens. We got 50 inches. Whatever we put it in, we open it up to that extent. These are the Phoenix Rescue Tools. I hope you've enjoyed what you've seen, and this concludes our brief presentation. Thanks for your attention. If you have any questions, just give us a call. Thank you very much.